All right, so this lesson is topic 6.4, and we're going to talk more about accumulation functions, and we're going to talk about the fundamental theorem of calculus part 1. All right, so an accumulation function outputs the area under the curve for some starting value 2x, which is the end point. Sorry, the input, sorry. All right. So, as a lot of times, accumulation functions are represented by capital F of x. So we have the integral from c to x, where c is the starting value. It will be some kind of constant. X is the same x as that, and they're both the independent variable. All right, and then it's going to the integrand is going to be f of t dt, where f of t is the rate of accumulation. So it's kind of like when we were accumulating snow, but now we have all the calculus symbols in it. Okay. So I'm going to come down and do a few problems using that formula, and then we'll talk about the fundamental theorem of calculus part 1. Okay. And so we have a graph of f of t shown. So this is a graph of f, right? And h is an accumulation function. And so h is equal to the integral from -2 to x of f of t dt. And the first problem we're going to do tells us to find h of 2. All right. So h of 2 is going to be equal to the integral from -2, which is this one right here, and then we're going to put what we're evaluating in for the top one. So from -2 to 2 of f of t dt. All right, so what that's asking us to do is find the area between the function and the curve. Whoops, I went too far. From -2 to 2. All right, so that area right there. All right, so that's just the area of a triangle whose base is 4 and whose height is 4. So that's going to be 1/2 4 times 4, or 8. So that is going to be 8. All right. If we want to find h of 8, same thing. We're going to do the integral from -2 to 8 of f of t dt. All right, so that's adding the areas from -2 to 8. And any area that's below the x-axis, we're going to subtract. All right, so this is an identical triangle. So base is 4, height is 4. So that's still going to be an area of 8. This is 1/2 2 times 4. So that's going to be 4, but since it's below the x-axis, we're going to call it -4. So that's going to be 8 plus 8 minus 4, which is 12. So that's asking us kind of to do stuff we've already done, just with a different notation. Okay, now the fundamental theorem of calculus part 1 deals with the rate of change of an accumulation function. So we're going to find the derivative of accumulation function, or an integral. All right, and what you're going to find, and we're going to show this down on number 3, what you're going to find is the derivative undoes the integral. All right, and what happens is the variable t just gets replaced with the variable x. And so you just end up with f of x. Okay, So we need that to do the next problem. So the next problem asks us to find h prime of 8. So let's just start off and we're going to find h prime of x. So that's going to be the derivative of f of t. So we're going to go from -2 to x, f of t dt. All right. And according to the fundamental theorem of calculus part 1, if I'm finding the derivative of an accumulation function, it's going to take that x and replace the t with it. It's just going to give us f of x. All right, so that means that h prime of 8 is f of 8. Right, and then when we have the function f, the value of the function when x is 8 is -4. So that is it. All right, and then for D, we want to find h double prime of 6. All right, so if we want to find the second derivative, what we'll do is just take this first derivative right here, and we'll find the derivative of it. So h double prime of x is going to be equal to f prime of x. All right, and f prime of x is the slopes of the graph of f. So h double prime of 6 is f prime of 6, which is the slope of the graph when x is 6. And to me, that's going to be down 4, right 2, down 4, right 2, or a slope of -2. All right, then on this one, we are going to let y equal that accumulation function for the integral from a to x of square root of 2 plus e to the 3t dt. So we're going to find the derivative of this. And all that's going to involve is using the fundamental theorem of calculus part 1, where we just take that x and put it in for the t, and that's it. Right. And then for number 3, this one is, I like this problem, but we have to think about it. So we're going to let g be the accumulation function. That's the integral from 1 to x of 3t plus 5 dt. And we're going to find a formula for g of x that does not include integrals. All right, so I know that 3t plus 5 is a linear function that has a y-intercept of 5 and a slope of 3, so something like this, straight line. And we're accumulating the areas from 1 to whatever x ends up being. All right. And then I know if I take 1 and I plug it in here, I'm going to get 8. So the value of the function 3t plus 5 when t is 1 is going to be 8. And then the value of 3t plus 5 when t is x is going to be 3x plus 5. All right. And then that formula is accumulating the area. So that formula, or that equation, really is the area of this trapezoid. So I can find the area of that trapezoid. I know how to find the area of a trapezoid. So g of x is that area that area is going to be base 1, which is a height of 8, plus base 2, which is a height of 3x plus 5 over 2, times the width of that trapezoid. And that trapezoid width should be x minus 1, because this distance is x, and then we take the distance of 1 away, and it gives you that. All right. So I'm just going to multiply. Well, I'm going to first combine some like terms. All right. And then I'll multiply that numerator out. Oh, wait, sorry, that's a 13. Okay, so that's a way to represent g of x without an integral. Now, part B tells us to find g prime of x. So using that polynomial function we just found, we just use the power rule to find the derivative. All right, and then we're going to compare what I just got with the fundamental theorem of calculus. So basically, the fundamental theorem of calculus says if we do the derivative of the accumulation function, it just basically cancels out everything. You're left with the integrand with x as your variable. And that's what happened. That's exactly what happened. So the derivative of the accumulation function is the integrand with an x. All right. So what I want y'all to do for your assignment is on page 290. Now, I want you to do number 74, but I want you to change it. So I know this is kind of weird. But I want you to change 74D to find g prime of 2. And then I want 74E to find g double prime of 3. All right, and then I also want you guys to do 81 through 86.